Welcome back to our introduction to automation. This is the fourth video in the series that looks at relays and relay logic. This one will introduce us to relay logic's descendant, ladder logic.
Relay logic established the standard visual language. Two vertical power rails, L1 and L2, were drawn on either side. Horizontal circuits, called rungs, were then connected between them. Input contacts and decision points were normally placed toward the left, with the output they controlled placed toward the right. Reading from left to right, you could follow the conditions, decisions, and resulting action, almost like reading a sentence.
This method of viewing logic was adopted for PLC programming. On the right is the same relay logic we just examined, now adapted as a PLC ladder diagram. The physical switch symbols have been replaced by PLC instructions. They may look like relay contacts, but they are not contacts. They are instructions telling the PLC to examine the state of a particular address or named memory location. That is a key distinction. Electricians connect physical devices, while programmers write instructions that refer to those devices. Without meaningful names or documentation, however, these instructions provide very few clues about what they represent or why they are there. The biggest difference becomes clear when we go online with the PLC and watch the program operate.
When you are online and the PLC is executing its program, you can watch the logic operate in real time. If an output is not energized when expected, the electrician can locate its output instruction and examine the controlling rung. Starting at the output and working back through the supporting logic, they can find where the highlighted path stops. That identifies the condition preventing the output from being energized.
The blank white spaces are reserved for documentation. The operating status tells us what the instructions are doing. Documentation tells us what they are supposed to accomplish. Without that documentation, much of the program has very little meaning.
Here, we have the same process represented in two different ways. On the left is hardwired relay logic. On the right is PLC ladder logic. An electrician reads both diagrams the same way, from left to right and then down to the next rung.
But the two systems do not execute their logic the same way.
No, they don't. In a relay circuit, when a relay closes its normally open contacts, every device receiving power through those contacts responds as part of the same electrical event.
Exactly. However, a PLC follows an ordered program. It evaluates one instruction after another and one rung after another. A decision made on an earlier rung can affect the logic that follows it. If the same output is used more than once, the last instruction controlling it determines its final state. If a timer's condition changes after its rung has already been evaluated, that rung will not respond to the change until the program is scanned again. Just as relay systems have supporting diagrams showing device locations and wiring, PLC systems also require electrical schematics in addition to the ladder program. These schematics show how power and control wiring connect real-world devices to the PLC input and output terminals. An input device, such as a push-button, limit switch, or sensor, is wired to an input module. An output device, such as a relay, solenoid, or motor starter, is wired to an output module. The I/O modules interface these electrical signals with the PLC's internal bus or backplane. The schematic therefore connects the physical world to the program. It tells us which real device is associated with each PLC input or output.
In our next video, we are going to look at some typical relay applications that are still in use today. As always, if you have any question or suggestions, put them in the comments. Click subscribe if you want more content alarms. Thanks for watching. Our next video will be on typical relay circuits.